Okay, guys, this one is the big dance, right? This is Free Fall Problems 3. This is where you're combining everything that you know from the last couple of days. Um, so this situation is a man throwing a ball horizontally, or a woman, throwing a ball horizontally at some speed. So I'm going to say the initial velocity horizontally was 10 meters per second. Okay, so if I happen to throw it 10 meters per second, there are a couple things I'm going to want to know, but basically I want to know how far off the cliff it's going to go, right? How far from the base of the cliff is it going to hit, or what's my distance in the x direction, right? This is what you got to do, okay? We understand that if I had dropped a ball, remember I do the marker trick, if I throw a marker and drop a marker, they hit the ground at the same time. So this ball, even though it's traveling in the x direction, is also falling downward, right? It's falling from rest. So when I figure out my distance, right, which is 80, I already have it, I will use this equation. My initial velocity in the y direction would cross out, right? So my equation I got to use for the y-axis, we did this a couple days ago. The distance in the y is equal to 1/2 gt squared, 1/2 gt squared. So I can figure out the time if I rearrange this and solve for t. I'm going to show you how to do that real quick. So to get rid of this half, I'd have to multiply by 2 on both sides. 2 times my distance equals gt squared. Then I divide by g on both sides. 2 times my distance divided by g equals t squared. And then I have to get rid of a square by square rooting it. Okay? So to find my time in the y direction, because it has gravity in it, I have to use this equation right here. Square root of 2 times my distance, my height, divided by gravity, which is 10. Okay? In the calculator, make sure you put parentheses on this. This is the big equation we have to use today. Make sure you get this one. If you don't get it, you don't remember to use it, you're going to mess it up big time. Okay? But everyone should be able to do this. Okay, so I'm going to just make it easy. Go ahead and put this equation right here in the y-axis. Okay, this is how you get the time given the height. Okay? This is the first step you got to be able to do. Figure out the time. Okay? Figure out the time. Time comes first. You need to know the time. And you know the time based on the height. Okay, let's try this one down here. This is 45 meters. I'm going to use the exact same equation, not question. First step, you got to figure out the time. And what was that equal to? I'm going to copy this guy. Okay, that's my time. Time equals 2 times my distance divided by g, and then the square root of that. Okay, so this is the first step I have to do. First step, I have to find time. Let's do that here. Okay, so let's plug it in. 2 times my 80, and then divided by g. What's g? It's 10, right? So then you put in your calculator. 2 times 80 divided by 10. Square root of that, you get 4. 4 seconds. Okay, that's important. Because if you know this is 4 seconds, that's going to help us with our dx, our distance in the x direction. There's no acceleration going this way, so instead of crossing out the initial, guess what happens to my acceleration? There's no g, right? So this term cancels out. But to figure out dx, it's velocity initial times time. And I have to use my velocity in the horizontal direction, so it would be 10. 10, the 10 right here, times my time, which is 4. So I would go 40 meters. I would travel 40 meters in this axis. Okay, let's go down here. So again, my time comes first. I go 2 times my height over g, which is 10. Square root that. We get calculator 3 seconds. Okay, we use that 3 seconds to figure out the x-axis distance, right? Now remember, since I don't have acceleration, there's no force of gravity pulling me in the x-axis. I get to do this. What happens to, there's no g, right? It's just 0, so it's going to cancel out. So my distance in the x-axis is just going to be velocity initial times time. And let's say I threw this ball with a speed of 5 meters per second. Just making that up, okay? If I happen to throw the ball 5 meters per second, I would plug in 5 meters per second, and then my time is 3. So I get 15 meters. That's how far I would go. Okay. One more. Let's do one more. got a guy on a cliff. He throws a ball at 15 meters per second, horizontally, right? Ball's going to do this. We know that the ball is going to go to the right and also downward. It's going to free fall as if it were just dropped, okay? So first thing I got to do, let's say my height is 151.25 meters. I just made that up for a convenient reason. Don't worry about it. First thing I got to do is what? Figure out my time. My equation for time, square root of 2 times my height divided by g, right? And that's how you're going to be given this, okay? Okay, so square root of 2 times 151.25 meters over 10. And we're going to get a very convenient number. It should sound familiar from yesterday. Square root of 2 times 151.25 divided by 10. You get 5.5. 5.5 in time is measured in seconds, right? So that's my time it'll take for this ball to hit the ground. But now, how do I figure out my distance? Do I go like this? 1/2 gt squared? No, it doesn't work because there's no acceleration in the x-axis. Okay. So I go distance is velocity initial times time. My velocity initial is 15 meters per second. My time is 5.5 seconds. So boom, seconds cancel out. 15 times 5.5 is 82.5 meters. That's how far it would go, 82.5 meters. All right, good job.